Alright guys, welcome back to another video. Here we're going to be looking at kinematics as a part of calculus. And yeah, this is going to be basically everything you possibly need to know about kinematics when it comes to IB Math HR, including some special formulas which you won't really find on the formula booklet. Also, all the keywords that you should be looking out for in questions. So like when you see that keyword, you immediately know what to do. So let's dive right into it. First, we need to understand the basics. And if you guys know, you can just like skip ahead a bit so that you can go into the keywords and the special formulas, which is really the meat of this video. Okay, so first we need to understand what displacement is. So you probably know what distance is. Distance is like the length between one place to another. But then displacement is a vector quantity, which means not only does it have a magnitude, but it also has a direction. When you move an object from one position to another, you can take any sort of a path. For example, if you want to go from one point to another, you can go like this or like this. So if this is 10 km, this is 2 km. Well, if the object takes the 10 km path, the distance covered by the object is obviously 10 km. If it takes the 2 km path, the distance is 2 km. But regardless of which path it takes, the displacement would always be 2 km, because displacement is basically the shortest distance between the origin and the destination. So 2 km is the displacement. By right, you're supposed to mention the direction in which the object has moved as well. Velocity is the vector quantity of speed. Speed in the general sense is how fast an object is moving, but velocity is how fast an object is moving in a specific direction. The definition of speed would be the change in distance per unit time, and the definition of velocity would be the change in displacement per unit time. So basically, when we think about changes, and that too since we're doing math, you probably know that calculus is involved already. So we can simply write velocity as ds by dt. Basically the change in distance per unit time where t approaches 0. So that's basically what velocity is. Likewise, acceleration is the rate of change of velocity. So how fast the speed of an object is changing. I'm sort of rushing through these because I'm quite sure that most of you guys already know this, but if you guys want me to make a more comprehensive video on the basics, I would love to. Just leave a comment below. Most of you guys already know that integration is basically anti-differentiation. So when you have to differentiate to get from velocity to acceleration, well, you have to integrate to get from acceleration to velocity. So if you want to write velocity in terms of acceleration, well, it's just the integral of a with respect to time. Over here, everything is respect to time, because by definition, it's always per unit time. And likewise, to get from velocity to displacement, we basically use s to denote displacement, even though it's kind of confusing, but yeah. And then we go ultimate basics, and like these formulas you probably should know. One more thing is we can write acceleration in terms of displacement. Since a is equal to dv by dt, since v is equal to ds by dt, to get from s to a with differentiating twice, you can write this as t square s by dt square. So this is another formula which would be of great use. Yeah, this is somewhat self-explanatory, and like, yeah, it's a formula you should probably know. But now let's come to the special formula, which I like to use to save a lot of time in my papers. This formula might look a bit weird, but yeah, this is a very important formula which I strongly recommend that everyone learns, because yeah, this can save you a lot of time, and sometimes the variables they give is just perfect for this formula, such that you can substitute this directly in here and get the solution, and yeah, the examiner will give you full marks. So how exactly did we arrive here? So as you know, acceleration is basically dv by dt as shown over here, and now our goal is to introduce a new variable ds. So how exactly do we do that? Well, we can take dv by ds into ds by dt. So as you can see, the ds here and the ds here cancel out, and that's how you get dv by dt. But yeah, our goal isn't to cancel out the ds and ds, so we can basically write this as, if you notice ds by dt, you can directly find out that ds by dt is nothing but velocity. So that's gonna be dv by ds to velocity, and yeah, there you go, that's the formula. All right, so now let's look at some of these practice sums so that we can note down keywords which are recurring in many of the sums, so that as soon as you see those sums, you will immediately know what to do and you can like solve the sum super fast. You can look at the sum, you can read it through, and it's a very simple. Find the initial velocity. This is your first keyword. Initial velocity means velocity when t is equal to 0. And over here, point O is nothing but the origin. Alright, so the point from where it starts. At t is equal to 0, the particle will be at the origin. What is the initial velocity? Basically, since we already know that v is equal to t square minus 6t plus 8, we just substitute t is equal to 0 into this, and we get 0 minus 6 into 0 plus 8. So v is equal to 8 meters per second. Usually, if they have given any information about the direction, you should probably include that in your answer. That was pretty simple. So your first keyword is instant velocity, and then your second keyword is instantaneously at rest, which means the exact point or the exact value of t where the particle is not moving at all. When the particle is not moving, obviously its velocity is equal to 0. Along its trajectory, a particle may stop at different points, and you should also know that every time it changes its direction, for a split second, it's actually instantaneously at rest before it changes its direction, because it can't just directly go into the other direction. So since we know v is equal to 0, well, we already know that v is equal to t square minus 60 plus 8. So when we substitute 0, yeah, it's just a simple quadratic equation. Well, let me just solve this super fast so that, yeah, this is very basic. You should probably be knowing how to do this. The particle is instantaneously at rest is t. Now these two have been quite simple, but now let's look at the other keywords which you should be knowing. Find the distance traveled by the particle in the first second, like between t is equal to 0 to until t is equal to 1. So basically we do not know an equation for displacement, so we have to derive that first. So that's basically v dt. So s is equal to, since we know that velocity is equal to t square minus 60 plus 8 with respect to time, well, that's going to be the displacement. And a quick thing you can do to find the displacement directly between these two times, actually not displacement but the distance, because yeah, that's what the question mentions, is just 0 to 1. But beware of this. You can only use this if you for sure know that the particle is not instantaneously at rest anywhere between these two times. We already know that from the previous sum, as it's only instantaneously at rest at these 2 points, which is both after t is equal to 1. Because if any time a particle is instantaneously at rest, that means it changes direction. So when it changes direction, the trajectory is no longer straight. It's more like this, something like this. When the trajectory is no longer straight, distance is not equal to displacement. So if you directly substitute, for example, 0 and 3, the solution will be the displacement and not the distance. And yeah, that's not the correct answer because it's asking for distance. So in this case, it's safe to use this method because there's no points at which the particle is instantaneously at rest before t is equal to 1. But if it were t is equal to 3, it would be a different process, and we'll look at that in the next question. So yeah, 1, t is equal to 1. So basically, if you integrate this, so I'm not going to go through the complete integration process because that's very simple. So after all the substitution, you would get 16 by 3. If you're doing this on a calculator, always use a modulus sign inside the integral sign because distance is always positive. This is the solution, 16 meters. Let's not forget the units. Now let's find the distance traveled by the particle in the first 3 seconds. And now it gets tricky because, as I explained previously, the path is no longer this, because we found out from 2 questions ago that the particle stops at t is equal to 2. So around t is equal to 2, it stops and then moves the other way for another second. So if we were to directly integrate it like this, well, we'll get the displacement, which is this distance right here. But we do not want that. We want the whole distance. So but there is no direct formula to calculate distance, so we need to find the displacement between 0 to 2 and the displacement between 2 to 3 and then add them up together. Let's look at the displacement between t is equal to 0 to t is equal to 2. So basically that would be 0 to 2, and then integral of t square minus 60 plus 8 dt, 20 by 3. And then now we're gonna calculate the second distance between t is equal to 2 and t is equal to 3. So that would be 2 to 3. The same thing. I'm not gonna go into the integration, and that would be minus 2 by 3. As you can see, the negative sign here indicates that it's been displaced in the opposite direction to the original direction in which it was traveling from 0 to 2. So you can see there's a change in direction. But since we're calculating distance, we're gonna take it as 2 by 3, because distance can never be negative. It's a scalar quantity. So basically just add up s1 plus s2, which is 20 by 3 plus 2 by 3, which is 22 by 3. After this, the next keyword we're going to be looking at is in the 5th second. It actually means the distance traveled between t is equal to 4 and t is equal to 5. So again, this is really simple. 4 and 5, and just do the integral process again, and that would be nothing but 4 by 3 meters. So yeah, quite simple. And lastly, find the acceleration at t is equal to 5. This is super simple. We know that velocity is equal to t square minus 6t plus, and we know that acceleration is equal to dv by dt. So we basically differentiate this, and we find that this is equal to nothing but 2t minus 6, and then we substitute t is equal to 5, and the acceleration would be nothing but 4 meters per second square. That's basically it. So the key words we're basically looking at are, well, initial velocity, and remember that it's t is equal to 0, then instantaneously at rest, which means v is equal to 0, and then in the first second means between t is equal to 0 and t is equal to 1, and in the first 3 seconds means between the first t is equal to 0 and t is equal to 3. But since it's distance and not displacement, and since we know that it stops at t is equal to 2, we have to calculate from t is equal to 0 to 2 and between 2 to 3 separately the displacement, and then add the absolute values together to find the total distance. And in the 5th second means from t is equal to 4 to t is equal to 5. And if they ask us to find the acceleration at t is equal to 5, well, that's super simple. Just derive the formula and substitute the values in. So these keywords are basically super helpful, and as soon as you see them, you know what you need to do, and you just go for it. Practice a few sums, and kinematics should be super simple. And yeah, this formula is something you should remember, as it can save you a lot of time. If you want to see this formula in use, leave a comment below and I'll definitely make a video on that. Thanks for watching, and I hope this video helped you, and I hope it helps you save more time and get better grades in your paper. Thank you.